Okay, so we're going to be doing velocity and acceleration today. So first of all, we have the position function, which is s of t. And then we have velocity, which is the derivative of the position function. And then we have acceleration, which is the derivative of the velocity function and the second derivative of the position function. So there's some little tips right there. And we're going to dive into this. Please watch my other videos on derivatives if you don't know what it means or if you haven't worked with derivatives before. Okay, so we have the position function, so functions of time. It's usually s of t or d of t, but it could be any variable here. And then we have the velocity function, which is, as I said before, is the derivative of the position function. And it's measured in meters over seconds or kilometers over hours, usually in meters per second, but it also depends on the question. And then we have the acceleration function, which is the derivative of the velocity function and the second derivative of the position function, as said before. It's measured in meters over seconds to the power of 2. So whenever you're finding the answer, you must put units. When you're finding the velocity or acceleration. Underline that a lot. So acceleration is the change in velocity over time. I'll give you a moment to write that down. Moving on. So determine the velocity and acceleration functions for each position function. Now, we're looking for the function. We're not actually calculating the velocity or acceleration. We're just finding the derivative or the second derivative of the position function. And with that, we're going to use the power rule, mostly. Unless it's, we're also going to use the product rule, I believe. So let's begin. So we have our velocity function, and then we have our acceleration function. So yeah, that's basically it. And we're going to do the same thing for this function right here, except we're going to use the product rule to find the derivative. That's the product rule right there. Okay, so we used the product rule to find the derivative of s of t, aka the velocity function, and we were left with negative 20t minus 7, and then we found the second derivative of s of t, which is the derivative of the velocity function, aka the acceleration function, and that is negative 20. A lot of the time, you'll just have a numerical number here. It won't be paired with any variables. Just because when you're finding the second derivative, usually the exponent is not more than 2 or 3. So the second derivative is just a number. Okay, so now our question is determine the velocity and acceleration at t equals 2. So for this one, we're going to be finding the velocity and acceleration function, and then we're going to be inputting the numerical number of 2, t equals 2, into the functions that we find, or the derivative of the s of t, or the second derivative of s of t. We're going to be inputting t equals 2 into those functions. But we cannot forget the units. Velocity, meters over seconds, acceleration, meters over seconds squared. I'll give you a moment to write this down. So the step that we did before was that we found the velocity and acceleration functions by finding the derivative and second derivative of the position function, which is s of t, that we see right there. And right there. So that's what we did. We found the derivative and the second derivative of s of t using the power rule and the product rule. But now what we're going to do is we're going to input t equals 2, because that's what it says in the question. We're going to input t equals 2 into those functions, and then we're going to be left with an answer, and we have to use these units to pair with our answers, and that is how you find velocity and acceleration. And after this video, there's going to be a video on velocity and acceleration word problems, and these word problems are going to be using the tools and what we've learned in this video. We're going to be using that in our applications, and we're going to be analyzing the questions, and we're going to be learning how to deal with velocity and acceleration in a really good way. So I hope that you've written that down. That was really important, so he left it up there for a really long time. Okay. Two to the power of 2 is 4. 4 times 3 is 12. 6 multiplied by 2 is 12, so minus 12 plus 1 equals 1 meter per second. Okay. So we have our velocity function right here. What we need is the derivative of that function. So 6t minus 6. It's 12 minus 6, which is just 6. There we go. So, to finalize our answers, velocity is 1 meters per second, and acceleration is 6 meters per second squared, or 1 meters over seconds, and then 6 meters over seconds, a second squared. Okay, so for this one, I am going to expand out before we find the acceleration and velocity, instead of doing the product rule, just because I have this t right there. So just plug this into your calculator, and you should get negative 95 meters per second. Plug this into your calculator, and you should get negative 86 meters over seconds squared. Let's do that circle again. There you go. Okay, I'll give you a moment to write that down. Okay. So, So I was left with, for the acceleration function, I was left with negative 9.8. Sorry for coughing. That is the acceleration, negative 9.8 meters over second squared. Because there's no variable attached to it, that's just the acceleration. Moving on. Now, because this is I believe it's a difference of squares, I'm not entirely sure. But this would be really easy to factor out. So, because of that, we just expanded, and then we're left with our function. And then we can find the derivative of that function, then the second derivative of that function, and then when we input t equals 2 into the velocity function and the acceleration function, we should find our answer. Okay, so our velocity is 32 meters over seconds, and our acceleration is 48 meters over second squared. Okay, that's all I have for you today. We're going to be doing some applications with velocity and acceleration next, and I'm going to do my best to really explain the questions and what you're supposed to do. Thank you very much for watching, and I hope you've learned something.